Surprising and unexpected changes in the planet Neptune. We give you a cordial welcome to this new documentary. If it is the first time, I introduce myself. I am the engineer Hiddekel Morrison, and I appreciate you decide to see this educational content, where you will learn the results of the most recent scientific research on the mysterious planet Neptune, the strange diamond rains that are in Neptune, and many other relevant information from the perspective of an engineer. Let's start. The planet Neptune, the eighth planet in distance from the Sun and the farthest in the solar system, is experiencing unexpected changes that have surprised the scientific community. This intriguing planet is one of the so-called icy giants, with an atmosphere composed mainly of hydrogen and helium, with an interior composed mainly of ice and rock. Its blue color is due to traces of methane in the outer peripheral regions, this generating the optical effect in the vivid blue appearance of this still very unknown planet. Among the many efforts that have been made to learn more about the planet Neptune, it was possible to capture this video sequence with data from the observations of the Hubble Space Telescope observing Neptune to show the blue-green planet rotating on its tilted axis. Some of the moons or rocks orbiting Neptune were also recorded for the first time. It was also, thanks to the Hubble Space Telescope, that, for the first time, time-lapse images of a large dark storm on Neptune disappearing were recorded, providing a valuable map that allows planetary scientists to see changes in formations such as the dark storms of Neptune. But one of the most impressive scientific studies was the one that unfolded in 2017 when an investigation confirmed the experimental hypothesis that 200-kilogram diamonds rain on Neptune, and that this rain occurs about 8,000 kilometers below the surface of this enigmatic planet. It is the most recent study of the year 2022 that has left scientists without answers, due to the unexpected changes in Neptune, which we detail and analyze below. But first, I ask you to support us by liking this video, sharing this video with your contacts, and subscribing to this channel, turning on notifications, so with your support, we can continue to frequently generate interesting documentaries on aerospace technology and the universe. Thank you for contributing to the creation of educational content. The name of the planet Neptune was put in honor of the Roman god of the sea, Neptune. With this study published in the Planetary Science Journal, the surprising fact that Neptune is changing in temperature was revealed. The observations of recent years reflect an unusual cooling during its summer, although there has been an impressive heating of the south pole of Neptune between the years 2018 and 2020. This research is the result of rigorous work by an international team of astronomers who used ground-based telescopes to measure Neptune's atmospheric temperatures over a 17-year period, discovering a surprising drop in global temperatures on Neptune followed by an impressive warming at its south pole. Like our planet Earth, the planet Neptune experiences seasons as it orbits the Sun. However, a Neptune season lasts about 40 years, and a Neptune year lasts 165 Earth years. Neptune's southern hemisphere has been in summer since 2005, and astronomers were eager to see what Neptune's seasonal temperature changes will be like. Astronomers looked at nearly 100 infrared thermal images of Neptune, taken over a 17-year period, to reconstruct overall trends in the planet's temperature in unprecedented detail. These data showed that, despite the start of the austral summer, most of the planet had gradually cooled over the past 2 decades. Neptune's global average temperature dropped by 8 degrees Celsius between 2003 and 2018. The team was surprised to discover in their observations over the last 2 years an impressive warming of Neptune's south pole. Temperatures rose rapidly by 11 degrees Celsius between 2018 and 2020. Although Neptune's warm polar vortex has been known for many years, it has never such rapid polar warming has been observed previously on the planet. The team measured Neptune's temperature using thermal cameras that work by measuring infrared light emitted by astronomical objects. For their analysis, the team combined all existing images of Neptune collected over the last 2 decades by ground-based telescopes. They studied infrared light emitted from a layer of Neptune's atmosphere called the stratosphere. This allowed the team to build a picture of Neptune's temperature and its variations during part of its austral summer. Because Neptune is about 4.5 billion kilometers away and very cold, with an average temperature reaching around -220 degrees Celsius, measuring its temperature from Earth is not an easy task. This type of study is only possible with sensitive infrared images from large telescopes, which can observe Neptune clearly, and these have only been available for the last 20 years or so. About a third of all the images obtained come from the Space Observatory in Chile's Atacama Desert, which, due to the size and height of the telescope's mirror, has a high resolution and high quality in the data obtained, offering the clearest images of Neptune. The team also used data from NASA's Spitzer Space Telescope and images taken with the Gemini South Telescope in Chile, as well as the Subaru Telescope, the Keck Telescope and the Gemini North Telescope, all in Hawaii. Since Neptune's temperature swings were so unexpected, the team doesn't yet know what might have caused them. They could be due to changes in Neptune's stratospheric chemistry, or random weather patterns, or even the solar cycle. More observations will be needed in the coming years to explore the causes behind these fluctuations. Future ground-based telescopes, such as the so-called Extremely Large Telescope, could observe temperature changes like these in greater detail, while the James Webb Space Telescope will provide unprecedented new maps of the chemistry and temperature in Neptune's atmosphere. Researcher Michael Roman, lead author of the study, stated, I quote, "I think Neptune itself is very intriguing to many of us because we still know so little about it. All of this indicates that the picture we had of Neptune's atmosphere and how it changes over time is more complicated than we imagined." End the date. How much did you know about Neptune? What do you think of these new scientific results? I will read your reflections in the comments of this video. As usual, we appreciate you informing us. It is a real pleasure to be able to provide you with the main news, trends and developments about the most important aspects of aerospace technology and the universe, from the perspective of an engineer. I am the engineer Hiddekel Morrison, and I invite you to meet again in a future installment.